Well, hello there. Sion Batson here from Sion Batson Tutoring, and in this video, we will be solving one-step inequalities. Now, this is part 2 of the series. In part 1 of the series, all of our solutions were positive integers. In this video, some of our solutions will be negative integers. So, if you need to review how to solve one-step inequalities, I recommend you go check out part 1 of the series first, Solving One-Step Inequalities Part 1. When you feel comfortable, you can come back and join me. Sounds like a plan? Perfect. Now, let's go. This exercise is out of my 7th grade math workbook. You can master 7th grade math, next generation learning standards. This workbook covers all of the next generation learning standards as well as all of the Common Core learning standards for 7th grade. This workbook is filled with very simple and easy to follow notes, step-by-step examples, guided examples, and more than 1,100 practice problems and answers. Parents love this workbook, students love this workbook, and the teachers love this workbook because it is a great resource for extra practice at home, for homework help, and it is the ultimate study guide to help your scholars get ready for the 7th grade state exam. So if you have a 7th grader, I would highly recommend that you get them a copy. You can get your copy from Amazon. Now, to our exercise. When solving one-step inequalities, our ultimate goal will be to get the variable we are solving for positive and on its side by itself. Now, to get the variable by itself, we will have to get rid of an unwanted company. To get rid of the unwanted company, we will use the opposite operation. Now, very important. Whatever the opposite operation is, we must perform that operation on both sides of the inequality. For example, if the opposite operation is to add 1, we must add 1 to both sides of the inequality. If the opposite operation is to add 2, we must add 2 to both sides of the inequality. So far, so good? Great. Now, there is one very important rule that we must remember at all times when solving one-step inequality. And the rule says, if we divide or multiply both sides of the inequality by a negative integer, we must reverse the inequality sign. Very important, yes? If we divide or multiply both sides of the inequality by a negative integer, we must reverse the inequality sign. Great? Perfect. Now, to our first example here. We have x plus 2 is greater than negative 1. Now, if you notice, the inequality sign, which is the greater than sign, splits the inequality into two sides. You have a left side and a right side. Our variable x is on the left side. So in this example, our ultimate goal will be to get the x positive and on the left side by itself. Yes? Now, to get the x by itself, we will have to get rid of an unwanted company. In this example, the unwanted company is positive 2. Look at this right here. If I get rid of the positive 2, the x will be on the left side by itself. So, how are we going to get rid of the positive 2? Well, since the 2 is adding, we are going to subtract 2 to get rid of it. Because remember, the opposite of addition is subtraction. So first, we will subtract 2 on the left side. If you subtract 2 on the left side, 2 take 2 is 0. So the 2 is gone. And that's the purpose of the opposite operation. The opposite operation eliminates or gets rid of the unwanted company. So after subtracting 2 on the left side, we have only x left. However, we aren't finished. Because remember, whatever the opposite operation is, we must perform that operation on both sides of the inequality. So since we subtracted 2 on the left side, we must subtract 2 on the right side. Negative 1 take 2 is negative 3. Now, we have accomplished our goal. The variable x is on the left side by itself. X is greater than -3. Very simple. Yes? No. This inequality is called a one-step inequality because it took only one step to get the variable on a side by itself. Very simple. Yes? Now, let's go one step further and graph our solution on the number line. Now, if you need to review how to graph inequalities on a number line, again, I recommend you go check out the video, Graphing Inequalities on a Number Line. When you feel comfortable, you can always come back and join me. Yes? So, let's graph x is greater than -3. So first, we'll place an open circle at -3. And since the inequality sign is greater than, we will shade to the right. And we're done. Yes? All right. Let's try the next one. Very simple concept. Very simple concept. Let's do -5x is less than or equal to 10. Yes, again, our variable is on the left side. So our ultimate goal here will be to get the x positive and on the left side by itself. Yeah? Now, to get the x by itself, we will have to get rid of an unwanted company. In this example, the unwanted company is -5. If I get rid of the -5, look what happens. The x is on the left side by itself. So how do we get rid of this -5? Well, remember, -5x is the same as -5 times x. So this -5 is multiplying the x. So since the -5 is multiplying, we are going to, very good, divide. Why? Because the opposite of multiplying is dividing. So we will first divide by -5 on the right, on the left side, sorry. -5 divided by -5 will give us 1. So on the left side, we have 1x. Now, remember our rule. Whenever we divide or multiply both sides of the inequality by a negative number, we will have to reverse the inequality sign. So let's go on the right side and divide by -5. 10 divided by -5 is -2. And because we divided both sides of the inequality by a negative integer, we will have to reverse our inequality sign. Our inequality sign is less than or equal to, so we'll change it or reverse it to greater than or equal to. So our solution is x is greater than or equal to -2. That's simple. Again, let's graph it. Let's graph our solution. Since the inequality sign is greater than or equal to, we'll have to use a closed circle or a shaded circle at -2. And since it's greater than, we will shade to the right. Again, if you need to practice graphing these inequalities on number lines, check that video out. Okay, all right, let's do one more, and then I'll give you guys a chance to shine. Okay, let's do a over 3 is less than, let's say, 0. All right, let's try this one here. So again, our variable a is on the left side. So our goal here will be to get the a on the left side by itself. To get the a by itself, we will have to get rid of the, very good, the 3. How are we going to get rid of the 3? Well, we'll use the opposite operation. Since the 3 is dividing, we are going to multiply the left side by 3. This 3 cancels that 3 right there. So we have a left on the left side. And if we multiply by 3 on the left side, we must multiply by 3 on the right side. 0 times 3 is 0. So x is less than, a is less than 0. So we place an open circle at 0 and we'll shade to the left. Very simple. Now, let me do one more. And then I promise I will give you guys a chance to try one. Let's do 7 is greater than x plus 5. Yes, 7 is greater than x plus 5. So again, in this example, our variable is on the right side. So our goal will be to get the variable on the right side by itself. Yes? To get the x by itself, we'll have to get rid of this 5. Since the 5 is adding, we will subtract 5. If we subtract 5 on the right side, 5 take 5 is 0, just the x is left. We aren't finished though. Remember, if we subtract 5 on the right side, we must subtract 5 on the left side. 7 take 5 is 2. So we have 2 is greater than x. However, remember with inequalities, we always want the variable to come before the inequality sign, yes? We always want the variable to come before or first, yes? So if 2 is greater than x, then x is less than 2. Make sense? If 2 is more than x, then we can also say x is less than 2. So we can rewrite our inequality. 2 is x is less than 2. Get the idea? So don't forget, whenever you have the inequality looking like this, where the integer comes before the inequality sign, you always want to reverse or turn that inequality around to make sure that the variable comes first. Yes? And again, once we turn the inequality around, we will have to reverse the sign. So x is greater than 2. So we put an open circle at 2, and then, x is less than 2, x is less than 2. So we'll shade to the left. Now I'm going to give you guys a chance to try one. Let's try negative x is less than 5. Let me see. Yes. Let me see what you guys will do with this one. Give it a try. Don't panic. Give it a try and then come back and let's see if we get the same answer. Pause the video. Now, welcome back. Let's see what happens. So first, our variable is on the left side. So our ultimate goal will be to get the variable on the left side positive and on its side by itself. First things first. Negative x is the same as negative 1x. That was the trick. And that'll be less than 5. So now you can see that you have to get rid of the negative 1 because our variable must be positive, right? Since we know that negative 1x is the same as negative 1 times x. So we will divide by negative 1. And after dividing by negative 1 on the left side, x will be by itself. If we divide by negative 1 on the left side, we must divide by negative 1 on the right side. 5 divided by negative 1 is negative 5. So x is less than negative 5. Great job if you got this answer. No stress if you didn't get it. Just see where you went wrong and make a note. Now, we can grab this on the number line. I'll extend my number line here to include negative 5. We'll use an open circle at negative 5 and we'll shade to the right. To the left. Oh my goodness. We will shade to the left because it is less than. How was that? Very simple, yes? Very simple. Very straightforward. I really hope you guys enjoyed this video. I really hope you guys will find it helpful and useful. Yes? Now, until next time, remember to practice, practice, practice. And also enjoy your homework. See you.